Now before this kid gets dealt drugs, let me give you a quick history lesson on methaqualone. Before I get into the science, I want to explain the history behind methaqualone. It was first synthesized in India in 1951, and in the 1960s the US, among other countries, began to do clinical trials on it. It was found to be a good sleep aid, and in 1965 it was approved by the FDA as methaqualone or Quaalude under William H. Rohr. It was very easy to prescribe, and by 1972 116 million units were sold, and it soon became widely abused throughout the world. It was abused because it offered sedation and euphoria. And in the 1980s, the DEA claimed it was the leading drug of abuse next to cannabis. In 1983, the last known manufacturer, Lemon, stopped producing tablets, and in 1984, it was placed in Schedule 1, further drying up the market. Now, before this drug takes its full effect, I want to explain the science behind methaqualone. Methaqualone, otherwise known as Quaalude, is a class of organic compounds containing quinazolines. An average dose would be 300 to 600 milligrams. The subject could stay awake. The effects are sedative and hypnotic. The high would last anywhere from 1 to 6 hours, and it stays in your system for 72 hours. Very early studies thought the drug operated the benzodiazepine site in the GABA receptor. But this was later found to be inaccurate. To understand how it works, you have to understand that there are multiple modulatory sites at the GABA A receptor. The benzodiazepine site is a popular one, and there are other sites for other drugs, like alcohol, barbiturates, and other general anesthetics. GABA A is made up of multiple different subunits, and different subunits functions result in a multitude of receptor complexes that respond differently to drugs. Methaqualone primarily functions as a positive allosteric modulator, or PAM, which alters activity by enhancing the effects of GABA. It can greatly increase the generated chloride currents, which are responsible for inhibiting neurotransmission and furthering the action potential. One of the big questions when studying the drug was, where does it bind? It was believed to use the benzodiazepine site, but that was wrong. Positive results were found in the transmembrane beta-alpha subunits. So to sum it up, when you take methaqualone, it causes the GABA A receptor to produce chloride ions, causing the action potential to go down, which slows the neurotransmission, making you feel sedated and relaxed.
A few moments later.